Thank you, Henry, and thank you to the University of Michigan for welcoming me here. Always a great to support our university transportation centers. And might as well get this out of the way. Go Blue! Congratulations. So my mom's actually a graduate of Michigan, 1961 with a math degree, in 1963 with a master's in math education. So I've watched many a Michigan football game. And so I was excited to see how that season is going this year. So I wanted to talk to you today about innovation and development, and in particular in connected and automated vehicles. And I want to ground that in safety and improving safety, improving operations of our highway system. And so I've never talked for 40 minutes, so we'll see how this goes. I'm not used to lecturing, but we got a lot of content. We'll see how it goes. And I got some stories to tell, some videos to really share some of the research we've been doing. I've been 25 years in the department doing ITS research, starting way back on collision warning systems. I talk about like the car you buy today with your advanced driver assist system. I worked with the auto industry in pre-competitive basis back in the late 90s, working on some of that technology to the most recent on connected vehicles. So we'll ground the conversation in safety and our national roadway safety strategy, and then sort of kind of walk through doing safety data analysis and making the case for why we're doing some of these technology approaches. We'll talk about just pure infrastructure design and kind of where that fits in, and then bring in connected and automated vehicles. And I think I'll end it with talking about my look at what a complete street is and the role of technology in that. So that's what we're going to try to do today. We'll start, the department, the USDOT released a national roadway safety strategy. Our goal is 0 deaths. That is the only acceptable goal. We're going to use the safe system approach and thinking about safer roads and safer vehicles and people, looking at the different design and speeds. And so as I go through the presentation, I'll talk a lot about speed and roadway design and vehicles. And just remember, I've spent the last 7 years in federal highway. And so I'm still adjusting to 2 months in the ITS program. So I must say we a lot, and I might really mean federal highway. But I've worked a lot in the ecosystem around vehicles and automation and highways and how we bring that together. And so when we talk about roadway safety, 42,795 fatalities last year, it's unacceptable. And that's a big number. And, where do we start? And you might be concerned like, well, we do this, it only does this percentage, or we do that. And so I like to talk about like a real story. And some of you have heard this. I talked about it a year ago. I talked about it a little bit more last month when I was up at the V2X Summit. And so in my neighborhood, there were in the last couple of years several bike fatalities. And so the roadway, which those people had a bike on, really wasn't set up as a bike facility. It was a high-speed arterial with a sidewalk, with a lot of entrances and exits. And unfortunately, 2 fatalities happened. And so, the county and the residents came together, and over a short period of time last year, they got the initiative to expand what was about a mile of bike lane to about 4 or 5 miles of separated bike lane. So it took a lane from the road. So there's 2 driving lanes and a bike lane with plastic pylons separating, which is great. And so some of you may say we've solved the problem. And in fact, the county did a study in the first 4 months. There were no fatalities. And the driving time, we took a lane. The driving time was minuscule, like 30 seconds longer over like 5 miles. So most of us would say that's acceptable to save a life. At the same time, there's all these folks who weren't used to that lane. And when they first building it out, and there's a lot of entrances and exits, And there's days like today when it's rainy and foggy, and you're driving in that lane and you're not used to what's going on, and you might want to turn right, and there's an electric bike coming in a bike lane at a speed you're not used to. And all of a sudden you're in a situation that is hazardous. And that's where connected vehicle technology and automation really can come in handy as another layer of information and warning. So the design's the first step. When the county went to design, the technology for connected vehicle wasn't stable enough to implement on our infrastructure, but we're getting there. And that's where we're at the moment of pushing wide-scale deployment. But I talk about this and I bring it up because 42,795 is unacceptable, but I'm sure each of you can think of someone in your neighborhood or your relationship that you know that has died in a motor vehicle crash. And I think we need to bring all resources to bear, and technology is one of them that we need to be considering. So the other side in our strategic planning is innovation and transformation. It's in the department's plan. I pulled out a slide from Federal Highway strategic plan, and it's really encouraging us to take risks and conduct innovative research and do it collaboratively, work with state and local tribal agencies, work with universities, work with industry to try to push the envelope and create something new. And so that's really what I've focused my career on doing research leadership and trying something new. And I'm really happy to see in our strategic planning the focus on zero, but the focus on creativity and innovation and how we go about doing that. So, when we're looking at safety, we have a wealth of data that we want to look at. And one of the things that has been alarming is the increase in vulnerable road user, pedestrian, bicyclists, people on scooters, fatalities. That's gone up 70% in the last several years. And there's been a lot of focus in how does technology, how does roadway design, what are the different approaches we can look at? And we've, as a department, also then looked at what are the situations that lead to it? What are certain states or localities that may have more challenges or opportunities? And so we've been diving into the data in different ways. Now, obviously, NHTSA puts out different information, and there's more fatalities at night in the middle of a roadway, generally speaking, men. But, there's a wealth of data we can dive into to try to understand this problem. And so now, as we think about how we look at that data, and I'll get to it more at the end with artificial intelligence and machine learning, but it's not just the fatality. We now can look at near misses, and we can look at other information, and I'll go through some examples that you wouldn't think about that could inform us in making better safety design choices that are now available to us. And so we really want to, do we have the tools as an industry to harness that different data? Do we have the access to those data sets? Is there open data? Is it shared? Do we have the space? Do we have the computing power? So we're looking into all of that. And how do we make an informed data-based decision? And so for a long time, we've been focused really on road design issues. And if we look at a lot of the data, runoff road is one of the major crash areas. And so state and locals have, with Federal Highway, a low-cost safety pool fund, and they've looked at different approaches. And this just kind of shows two different approaches that are available to us now, looking at high-friction roadways or looking at center lane rumble strips. And so, we looked at the data, runoff road, came together with folks and did different infrastructure pavement-focused designs that we can do. And those are some of the insights that the data analysis and so forth can provide to us. But if we want to think differently and think about different data sets that are available now through like NIH or housing or different things, we can inform some really enlightened and different observations. And so this picture, it shows a visualization of redlining information and sort of making different decisions about where people could get mortgages or loans or banking, and compared to traffic fatalities, and they look like the same. And so could you infer that some of our housing design decisions have impacted our infrastructure design decisions, which then have impacted, where and what roadway safety technologies or better roadway design or better lighting, or so I'm making some guesses on some of this data, but we didn't have the ability to kind of look at these insights 5-10 years ago, and we have it now. And so one of the real opportunities I pose to us is, what are the different communities we're bringing to the table, and what data do they have? And then what visualization and analysis tools can we bring together to learn something new? Because 42,795 fatalities are a lot, but there's usually one at one intersection, and then, one at another one. And so it's really hard to infer. It's not like there's 50,000 vehicles running through that intersection and they all crash. And so what are some of these other data insights? And I think that's a real opportunity we have now, and we have the tools to start to look at that. So we and Federal Highway, based on some of this, is creating PANDA. It's a Pathways to Advanced Novel Data Analytics. It's a new data science lab to try to uncover and look at some of these technologies and make available the capabilities. So we end up looking at data, and we do our best to assess, what do we do? Where's the problem? What kind of solution might make sense? And then we have to go and design something bold and big and different to create that. And so two of our very successful, one's longer term and one's newer, diverging diamond interchanges. And so the premise there is, if you can prevent left turn, crossing path scenarios, and design these interchanges to take away that maneuver, you can reduce fatalities. And so Federal Highway was working with the state of Missouri a long time ago, and actually our human factors lab was able to create the first diverging diamond virtually and create a human factors study to say, if you're having drivers do something that they've never done before, which is like cross on the other side of the road where they might feel uncomfortable, is the signage accurate? Can they follow that sign? Do they know what they're supposed to do? And so we were able to design in the virtual world a divergent diamond, build, run tests through it, clarify the signing, and then the state went out and built the first diamond. And now these are widely deployed all across the country. But it was thinking differently about, how can I bring my human factors and psychologists, design and sign design people with hard infrastructure design? This saves well over, I think, $100 million to build these interchanges in savings over another type of interchange. So there's significant investment. Well, now fast forward, and I talk a lot about pedestrian and bicyclist fatality increases. And so if we can create roads that separate the users in time and space, then we can make improvements to safety for all users. And so this just shows a more recent intersection. We can see where there's curbs are bumped out. There's paint to designate the different lanes. And so people can be separated and provide, a more comfortable place and safer place for them to maneuver. Around Ann Arbor last night, was able to see some of the bike lanes and stuff installed locally. One thing I like to talk about in back on the runoff road is some of the barrier testing that's been done at Turner Fairbank with the National Park Service. So if you look on the right side of this, you see a low stone wall. And so if you think about our parks, we want them to be pretty. We want them to have aesthetically pleasing, look like they fit in. And so you want a stone wall or a timber wall. Well, these were designed 50, 60, 70 years ago. Vehicles are bigger. That low wall in your F-350, you're probably thinking you're going right over it. So what could we do to create this aesthetically pleasing wall, but not have the cost of a full stone wall? And so we designed concrete inside, and you're just facing the barrier on the outside. And so we were able to work with the Park Service and our Federal Lands Office, create a new design, test it at Turner Fairbank. And actually, if you visited DC right now and drove on the GW Parkway, they're installing these new designs all across the parkway, and then soon to come across our national parks across the country. So it's just an interesting way to think about how Federal Highway might partner with a Park Service, but think about how do you keep something for the context that everybody wants. And our parks are beautiful, and we want to kind of think about that and design accordingly. So then we think a little bit more on the innovative infrastructure design. There's just a couple more designs around different cutouts and turning information, and how to separate through turns, and how to do additional safety measures for pedestrians and bicyclists. There's just a couple other pictures of some of the innovative designs that our community is starting to create based on trying the concept of safety for all users, and really thinking it's not just about how do we quickly get vehicles through, how are we safely getting everyone to the destination they want to go? Speed is another huge issue in the safe system approach. And so we've updated our speed safety camera guidance. You'll see states looking at how can you put like a speed camera in a work zone. So a lot of new capabilities. People are thinking about using technology, and it's not, in this particular case, it's speed safety camera, and the words and what we're trying to convey is we're trying to get you to drive safely and drive at the posted speed limit. The speed limit's reduced because you're at a work zone or you're near a school or a different scenario. So thinking about driver behavior and what are speed setting and how do we want to enforce that? We also have to think from an equitability perspective, who and how are we implementing this technology and putting it in places that really are focused on safety, and where they're speeding and where we don't want that speeding. In a work zone fatalities are going up substantially. School zones, we do not want people speeding in that. So this is a technology tool that's available, and we've created some operational guidance on that. So in this first part of the presentation, I really tried to just ground us on a lot more traditional speed setting, infrastructure design, and how traffic control devices and kind of that goes on hand in hand. But now let's move back into sort of what you all are here about in Center Connected and Automated Transportation. What does connectivity do to this situation, and what does automation do, and what are some of the opportunities? And so just last month, the department was here in Michigan, and we unveiled our draft national V2X deployment plan. So connectivity technology, looking at how we use the dedicated spectrum and 5.9 gigahertz for the safety of life applications using cellular V2X. Also, how we look at other technologies that maybe don't need the high speed, low latency bandwidth of cellular V2X capable technologies. And so we put out a draft plan to try to make sure the industry asked us to do that, to really lay out a vision for the nation, because in order for this technology to provide those life-saving benefits, we need vehicles equipped and we need infrastructure equipped. And we need to understand, the OEMs have asked, well, what is that vision? How many intersections, or is it going to be on our freeways, on major corridors? Where are you deploying this? And the infrastructure owner operators, well, when's the vehicle fleet going to get installed? So we've been bringing folks together to get input on that. The technology, working with FCC to kind of stabilize and understand what the status of the technology is, and is it ready for deployment, which it is. We also announced the new $40 million notice to try to spur industry to create new deployments that are focused a lot on generating benefits information over the long term on safety. And so I encourage folks, if you haven't yet gone and read the plan, we're asking for comments by the end of January, and the department's intent would be to create a new plan through the department in March, April timeframe of 2024. But when we're talking about this and innovation and collaboration, what has been the department's role? And so when the SCC indicated we really needed to use cellular V2X, we brought our industry experts together, and we didn't go to Willow Run, we went to Willow Grove. It's an airfield down in Pennsylvania, and we recreated a scenario that the department had done with CAMP, with 200 vehicles, essentially creating messages that broadcasting using cellular V2X, and did a scenario in which you're approaching an intersection, and would that vehicle get a warning for a red light violation type scenario. And so we did a lot of this testing to make sure the technology was robust and ready, so we could help then work with industry to move towards deployment. And so the department regularly collaborates with technology developers, with the automotive sector and IOs to understand what is the current state of play. In this sort of situation, the FCC have been encouraging us to change technology types. And the whole industry was like, we've used DSRC, we know how that works. And so we said, well, we can recreate that test and bring the parties together. We got equipment provided to us by major suppliers from the industry. It was their equipment. We set it up as if they were vehicles, and we're able to run these tests, and we've released the whole data set. So I only have 40 minutes. So I didn't give you the whole history of connectivity, and most of you all know that. I mean, you're the center that's thriving on that. We did the safety pilot here in Ann Arbor, so I purposely chose not to do too much of what is connected vehicle here, and I won't do a lot of what is automation. But you can't talk today without talking about connectivity and talking about automation. And you can do automated vehicles on their own. You can do connectivity on their own. You can do them together. And so what we've been doing in the department, one of the things is looking at what we're calling cooperative driving automation. And that is specifically trying to take the benefits of connectivity and automation, bringing them together to improve the safety, operations, and efficiency of the transportation system. And so Federal Highway, the ITS Joint Program Office, Federal Motor Carrier Safety Administration, FTA, and the Maritime Administration have all been working collaboratively on various different use cases to think about how we can do that. And we're working with NHTSA to understand sort of the safety and implications and state of play of the automation sector. And so we really are looking at how to enable a more efficient and safe system. And we're looking from a Federal Highway and departmental perspective is how do we enable this research? How do we foster an industry? How do we enable collaboration and innovation? And we chose to work a lot. When we started this program 5-6 years ago, I couldn't go to an auto OEM and buy an automated car. And I still can't go buy a level 4 automated car. So we had to create one There was a company called Autonomous Stuff that built them using AutoWare. We chose to move to work in open source so we could more readily share results and think about how to innovate and create an ecosystem that might want to work together. I was happy to ride in the car here at University of Michigan just half an hour ago, and you also have AutoWare software enabling the fleet of vehicles you have. So there's a lot of opportunity to collaborate and innovate when you're thinking about open source. And so we really have been doing the program for the last 6 years and worked with industry. We brought the state DOTs and auto sector together. What are some of the use cases which you thought cooperative driving and the blending of connectivity and automation may help? What are the messages beyond the basic safety message that might need to be sent between vehicles or between the infrastructure and a vehicle to enable these use cases? We then went and built out, defined the concept of operations design and built out these use cases and tested them. So the next few slides, I'm going to go through and talk about the testing that Federal Highway did with our fleet of, and motor carrier MARAD, our fleet of vehicles and trucks. And so the last several years, we've done thousands of miles. Yes, it's not millions of miles that our AV companies have done, but we've done thousands of miles using different test facilities. So one of the first tests we were able to do was looking at high-speed freeway scenarios around work zones, merging, and we did that at ACM, at the American Center for Mobility. Great to be able to come up to Michigan and use that facility to do high-speed testing that we couldn't do at Turner Fairbank, and it allowed us to do various different testing. We've done testing down at SunTrax in Florida with our truck fleet to leverage their test facility, and we've done some low-speed testing at Turner Fairbank, and then just recently we've used the virtual M-City and the digital twin of M-City to do testing that we just did a couple weeks ago with partners across the country. So it's really great that the community is stepping up with these test facilities, both in the real world and in the digital world, that we can leverage and enable different testing. And so we've come to the point, and after this, I think is when I'm going to show you some of the tools and then some of the videos. We've created various different open source products based off of our research that are freely available for researchers across the country and tech companies to consider using. One of them is a telematics tool looking at sort of the different communications capabilities, whether it's cellular V2X or cellular. Voices is our distributed testing capability and the ability to bring in different companies to test in the virtual world to see about interoperability and how use cases work. V2X Hub is our message handler. So if you're trying to send a basic safety message or a signal phase and timing message or a message around port drayage, which we did with MARAD and motor carrier, or truck information around truck weigh stations, we've done different technology tests with motor carrier around messaging there. And so the V2X Hub is how you send a message from the infrastructure out into the vehicles. And then our co-simulation tool is looking at how we bring different simulation tools together in the rural and digital world to do analysis.
Telematics tool was developed to help understand, track, and analyze the information used in these technologies. This visualization of various data sets is useful for a multitude of research endeavors involving connected and automated vehicles because it allows developers to immediately view and understand the relationship between various points of data in time. It also provides an easy-to-use dashboard that presents data visually so users can monitor, plot, and analyze the behavior of entities.
So when we were doing a test to look at how does an automated vehicle operate through a signalized intersection most efficiently. So it's receiving signal phase and timing, And actually we had 3 different vehicles approaching an intersection. And so the question is, which vehicle's going first? We're trying to optimize for gas and emissions. So vehicles were receiving signal timing in real time and trying to figure out, do I speed up? Do I slow down? And our researchers were trying to figure out, well, I need to understand what's going on. They're trying to look at the data and figure out, we said, you need a tool. And so we were able to visualize the red time, the green time, the yellow time, look at the speed that they were approaching. And so then we could do different scenarios where these vehicles would launch at different times. And so you could purposely have them all approaching at the exact same time at the intersection, and then see what would happen. Or you could have them approaching at different speeds at different times. So it's a really interesting tool. It's in open source that we have to really help visualize what's going on at an intersection and think about, you're also getting the basic safety message, so you understand the speed of the vehicle, you'll understand the signal phasing timing, and you can see what's going on. So we recently, in the spring, Omni Air held a Plug Fest down in Florida. And so this is where they bring companies, in particular, trying to build out the V2X infrastructure and onboard units, and they bring them in to test interoperability and add and implement what they did. So we took our fleet of automated trucks and we took a roadside unit that was provided by one of the suppliers, and we were able to have we basically created a scenario where we did it on our own first, where we had 2 trucks and a car that were approaching a work zone. And the message was for the car to move over 1 lane and the trucks to automatically move over 2 lanes, and all of them to automatically slow down as they're approaching a work zone. So, the scenario is, we want these vehicles getting away from the workers. We want everybody going slower. The infrastructure would send a message to the vehicle. So we did all that testing and development. We did the use case on our own. And then this Plug Fest happened shortly thereafter. And because of our open source development and the ability to have an ecosystem, within a week, we could take a couple of these suppliers and have their equipment inserted into a test we had done on our own, and it worked just the same. So that was really exciting for us to kind of look at the value of open source and innovation and how we collaborate differently. Another scenario is in the spring, we're down at SunTrax, and this scenario is a 4-vehicle platoon. The first 3 vehicles are the Federal Highway Karma fleet. The 4th vehicle is the University of South Florida. They had an automated vehicle, and they had used open source, and so we kept our fleet down for a week. They came over on their own research funding, and were able to do testing and development with us, in which they joined the back of our platoon. And so the situation was, the vehicles were merging onto the highway, and we wanted the vehicle to come and join the back of the platoon. And so we're only able to do that because of the open source development we've been working on, and we've been sharing the research with the community, and the university had been following it. They downloaded, used a lot of the software, and we were able to collaboratively test in the real world. So that was really exciting. We're really interested in trying to do more work related to that. We're also very interested in the work zone scenario. As I mentioned earlier, our work zone, a lot of fatalities are increasing in that area. And so could you send a message that you're approaching a work zone, the speed limit is reduced, you need to change lanes? In this sort of scenario, you also have, think of it more on our arterial, and maybe you have to have instead of having a flagger, which has one set of cars go through and then everybody stops and the other set of cars go through. What if you're just doing that automatically with virtual messages? And so we were able, I thought I had a video there, but I guess not. We were able to implement that scenario and send messages and have a vehicle automatically traverse the work zone. And so I talked a lot about, at this point, creating these use cases, and you might say, well, that's great. You've innovative, you're thinking about connectivity and automation. Is this really deployable? How can I, as an auto sector, rely on an information message? And so this slide's is talking really about, from a policy perspective, what Federal Highway has done with state and locals to really make this happen. And so in one situation is the work zone data exchange. So we created a standardized work zone data message. Because we created that standard message, state and locals know what data needs to go in regarding a work zone. So where's the work zone located? How long's the extent of the work zone? Is a lane closed or 2 lanes closed? What's the speed limit? What's the geometry of the work zone? We work with the auto industry to get input on what they may need. And we created a spec, and this slide's a little old. So there's 21 states that have the ability to generate that work zone data message and provide that. And there are real companies out there using that to provide digital alerting to drivers. And so you can get different work zone information. And right now it's helping with warnings. It's not doing anything on automation, but it is moving along there nicely. So we've hit this milestone in cooperative driving automation where we created a bunch of use cases, built and tested them, and it's feasible. We can create the messages, we can send them to vehicles in time for them to make the intended maneuver. But we've done this all on test tracks and with open source research quality capable systems. So now we want to move this to the real world. And so we would like to get to industry-developed on-road pilots. So where we're actually working with OEMs, we're working with state and local agencies to move this out of a test track and into the real world. And so right now, we're actually spending the next 6 months. We've Federal Highway, the department, we're going to have a listening session at Tier B. We're going to do something at Turner Fairbank, and we're going to do an event up here in Michigan, make it more accessible to the OEMs, which we're going to bring our fleet of vehicles, show them the capability that's been created, talk about the state of play of connectivity and automation, and understand what additional research do we need to still do to move when we're thinking about moving to an actual real-world implementation. What human factors work do we need to do? What standardization do we need to do? What test track work do we still need to do? What industry sectors do we need to bring together to collaborate and safely implement an on-road pilot like the safety pilot that you all did so well here in Ann Arbor? And so that's the stage we're at with cooperative driving automation. We know that the industry and the AV space is trying to make your individual AV safe and get it on the real road. And we're not trying to get in the way with that, but we know that as connectivity is deployed, and whether that's cellular V2X or cellular or something else, there is more that we can bring to the scenario to provide better information, another sensor, more information to help make informed decisions. So I've talked mostly about vehicles, but what about all users? And so we do have a lot in the world on pedestrian and bicyclist safety. We want to think about what happens if that pedestrian's in front of a transit bus at an intersection and you want to go around and can't see. Can an infrastructure sensor pick up that pedestrian and provide a shared message from the infrastructure to a vehicle? So that's a big part of space. And I know you have the smart intersection work here in Ann Arbor looking at that. So that's a big area we're very interested in. Artificial intelligence, we just had the presidential executive order related to that, looking at how we had safely advance artificial intelligence applications. I'll do a little shout out here to Peter Huang at Turner Fairbank. He's retiring this month. He championed AI in Federal Highway for traffic management center use for years, and he partnered up with Delaware DOT and Gene Donaldson, and they've implemented a lot of early uses of AI in traffic management. There's now the Exploratory Advanced Research Program. We're doing AI and cameras to do incident detection better. Obviously, AI is at the heart of automated vehicle, and it's at the heart of our intersection safety challenge. So I can't talk a lot about that today, but we're very excited. We had 120 entities apply, 180 different partners as part of those entities, and thinking about how you use technology at an intersection to better understand where the pedestrians are, where the vehicles are, use AI and machine learning to generate the messages to provide warnings as appropriate to improve intersection safety. We have a whole lot of work in analysis, modeling, and simulation. I talked a little bit earlier about the virtual world and thinking about different tools to bring together testing safely in a virtual world before you put it in a test bed or before you put it in the real world. It also, hadn't talked much about it, when we think about our role in working with universities and educating. There are universities that don't and can't afford to buy a $300,000 and build a $300,000 automated vehicle, but they have amazing simulation and modeling expertise, or they're experts in traffic to engage, whether it's algorithm development or simulation. So there's various opportunities there. And so the last couple slides, I'm just going to kind of bring everything together. We very much focused right now on complete streets and really safety for all users. How does that street provide the mobility you need, the delivery of goods and services, but get everybody there safely? And it's a design philosophy, it's a technology approach. And so I want to think about, when we are building, I thought I had a slide on here with an RSU situated on top of, on the bottom down there. So if we think about a complete street of the future, I'd like to ask you to think about this, and is it connected? Have we put in a roadside unit to share critical safety information about the signal phase and timing to enable a wide array of different kind of connected and automated services of the future? And so I think that's why you guys are here, why you're the Center for Connected and Automated Transportation, to help the nation think about what are the business cases, how do we bring this technology to deployment. And I was happy to be here to share some of the thoughts of some of the research we do, but I think this is just a great opportunity right now. All the Attain grants, the money is that we have $1 billion a year in safety deployment grants. We put in last year the ability to pilot connected vehicle technology, and to our knowledge, nobody proposed doing that. So, there's an education and outreach opportunity to state and locals about the value of connected vehicle technology. But there's also, it's a sign of last year, maybe there's still some uncertainty, but now with our V2X national deployment plan, I think, and the actions at SEC, that uncertainty is going away. And so I asked this community, and especially you here at Umtree and this UTC, to help us educate and have a national dialogue about the role of technology and automation in our system. So thank you very much. It's a pleasure. And we, I think, have some time for questions.
So we see that a lot of connected and vehicle work is being done under the auspices of the public sector in collaboration with the private sector. And all the autonomous vehicle work is almost being done solely in the private sector, some public sector overlap. And as we sort of move towards the common goal on both sides and kind of climb that pyramid, how do you see both of these working together, and what is US DOT's perspective of that?
Yeah, so just to ground, I will tell you, I'll give you the research perspective because that's where we are. I don't think the department is not going to come out right now on a policy statement around deployment. So just couch that as the answer. I'm coming to you from someone who's in research, right? And so a lot about what I talk to you is, we've been trying to say, is it feasible? What are the standards? What are the messages? What are the standards? What are the hurdles that we would need to overcome to bring this technology together? And so for the last 5 or 6 years, we've been in the early stage, and we've been working with SAE. There's a Cooperative Driving Automation suite of standards under development. And so that's a key first piece in sort of a federal role. Like we know, said earlier, the AV sector is trying to get safe automated vehicles deployed as fast as they can, right? And so if they have to rely on connected infrastructure that's not deployed, they're not going to get there. So, the question really becomes, okay, well then, but connectivity can provide additional situational awareness, additional information, maybe additional messages that could improve operations, improve safety over time. So how do we start thinking about that? And I think that's where the standards community weighs in. That's where Federal Highway and the department putting out this vision of this research lets people know this is what we're thinking about. So as those technologies come to market, FTA is funding Connecticut DOT and the transit agency there. They're implementing automated transit shuttle that is reliant upon having transit signal data to cross through intersections safely. So they have created a route that requires it. So you also have to be careful because it's not the whole automated industry, and it's what sector are you working on?
Yeah. So the question is how to get a car OEM get more involved in the deployment.
Of V2X or of everything or? Yeah. And so, obviously the V2X landscape has evolved a lot in the last 6 years. We have been working with the OEMs on pre-competitive work for a long time. You all brought them here in the safety pilot. And so what the OEMs asked us, and the Alliance indicated a year ago was we needed to resolve uncertainty. And so we made great strides with the FCC on the waivers, working towards sort of the second report and order that does final rules. And so those efforts will provide one level of message and information. Just last week, NHTSA pulled back the rule that was focused on using DSRC since that's not a viable option. And so now, if you think like what we're doing to move forward, they asked for what is the deployment vision. And so we have actually brought in 5GAA, the Alliance of Automotive Manufacturers, ASHO, ITS America, and ITE. They've got a smaller subject matter expert group that they're helping us look at all of the comments that we're getting in from the industry, the comments that we received last month. And we're really trying to put forward a national plan that is a shared plan that the OEMs, the infrastructure owner operators have provided input to and want to see happen. And so, I think our immediate step really for us at the department is getting that V2X plan published as a final plan in the spring. That'll come out, ideally through the department. And so we'll represent all modes. And so I think that's going to be a major statement. From that, then it's sort of see how deployment and, OEMs will have to make business decisions on their own.
Thank you. As if the problems that you've been talking about aren't complicated enough. As the technology evolves, how do you, maybe as a researcher, see getting pedestrians and vulnerable road users into the system sort of directly? Is that going to be a possibility? Indirectly, there can be sensors that detect pedestrians and report them to nearby vehicles.
Yeah. Yeah, I mean, so when I talk VDEX, I talk mostly about cellular VDEX and that technology. Obviously, cellular, I've mentioned that several different times. Many people have cellular phones, almost everybody, I wouldn't say everybody. And so there's certainly that sector of the industry that is very much looking at, is your cell phone and geolocation accurate enough on you, and how can that be representation to then enable where you're located. We've done research, even just sort of, if you're coming to a mid-block crossing and there's no technology there, could you have an app on your phone that indicates you want to cross there, and then you get a message broadcast out through the cloud to vehicles that you're trying to cross at a mid-block crossing where there is no technology. And so that's like a perfect kind of use case where cellular, you're trying to give advance warning that you're intending to cross. And so it's not a safety critical, you just stepped out when no one was looking, but you're there wanting to cross and you want to broadcast a message. So, I think it's a matter of what are the tools, what are the scenarios, and how do we bring people, into, I think, the bike community. There's a new consortium that SAE is pulling together, the ITC community that has OEMs, bike manufacturers, equipment suppliers trying to think about how do you equip a bike to be able to broadcast messages and so forth. So I think the ecosystem is coming together. I think the big thing is recognizing that pedestrians and bicyclists are users of the system. And more we want them to use the system. And you need to feel comfortable. You need to, which means you need to be safe. And so we need to be thinking about how to engage them in that scenario.
Hi, thanks for the presentation. I had a question about how can we consider human error in our V2X communications. I'm thinking specifically like, impaired driving is still a very large issue, especially in fatality scenarios. So how can we be thinking about, one of the lists when we talk about Vision Zero is accounting for human error. And so how can we account for that in this V2X application?
Yeah. Yeah, I mean, that's where some of this connectivity technology is another sensor. If you are going to do the best design in the world and a driver makes a mistake, and I talked about sort of the separated pylons in the bike lane, early on I saw people driving into the bike lane, they didn't know the bike lane used to be a mile and all of a sudden it was 5 miles. So then they didn't think it was there, or it was rainy and cloudy and foggy and they didn't know. Well, luckily there wasn't anyone biking in the lane at the time, but that's sort of that fog or low visibility scenario where connectivity can certainly, I think the crash that just happened in New Orleans about a month ago, where a huge vehicle piled up because the drivers couldn't see. And so, thinking and recognizing that drivers make mistakes, and how do you design that? And so from a pure design, you can separate users, you can put in a retaining wall, you can do different things, but you can lower speed. And so we're doing all of that. And then I think technology is another area that can layer in as well.